This is part 2 of section 2.1. We are still solving inequalities. We need to write our answers in interval notation, and we have to do a graph. I have negative 2m is greater than 10. Our first step would be to get our m term by itself. We already have that. To get the m alone, I need to divide by a negative 2. And I am allowed to do that. But since I'm dividing by a negative, I have to flip this sign around. Usually, whenever I realize I need to flip it around, I circle it. And that's because the next step is essentially a recopying step, and we have a tendency to mess those up because we think they're easy and our brain goes on vacation. Negative 2 divided by negative 2 is positive 1, so that's m. Flip that around, it's less than. 10 divided by negative 2 is negative 5. Okay, remember doing the graph is easier than doing the interval notation, so I'm going to put negative 5 on my graph. Now, what numbers are to the right? These are our bigger numbers. So negative 4, negative 3, negative 2, negative 1, and these are obviously not evenly spaced, 0. And these go smaller, negative 6, negative 7, and so on. I need to figure out what symbol to put on the negative 5. Since this is less than and not less than or equal to, we're going to use parentheses by this. We just have to figure out which direction. Okay, so I need my numbers, where my variable is. My variables are smaller than negative 5. Smaller goes in the left-hand direction. So I'm going to be talking about this area over here. And I get parentheses on it. Okay, so now for interval notation, it's always the left boundary and the right boundary. This goes off forever in the left-hand direction, and remember our negative infinities are over here. So my left-hand boundary is negative infinity, comma, my right-hand boundary is negative 5. Negative 5 gets parentheses because it did here. Infinity or negative infinity always gets a parentheses as well. So this is my answer in interval notation. This is my graph answer. Next problem. What we have here, we need to distribute this negative 2 first. So I'm going to take this and distribute through here. And I don't have to worry about this at all. I don't have to worry about this sign at all. It's only when I divide both sides or multiply both sides by something. So basically here I'm just rearranging. I have m minus 2m plus 8 is less than or equal to 3m. m minus 2m would be negative m plus 8 is less than or equal to 3m. Okay, so I've combined like terms over here, simplified this. Now I want to get my variable alone. So since this is my only constant, I'm going to move this over to here. And I do that by adding 1m to both sides. So I get 8 is less than or equal to 4m. Now I need to divide both sides by a positive 4. Since it's a positive 4, I do not need to worry about flipping my signs around. And I get 2 is less than or equal to m. Okay. This has a less than or equal to on it, so I know I'm going to be using a bracket on my graph. I just don't know which direction yet. I'm going to put a 2 here and some other numbers if it helps. Okay. Whatever numbers my answers are, they need to be bigger than 2. So 3 is greater than or equal to 2, 4 is greater than or equal to 2, but 1 is not. So I'm going to shade in this direction. And it's going to get a bracket on it. One note here. Some teachers teach that you always shade the direction your sign points. That does not work unless your variable is on the left-hand side. Since my variable is on the right-hand side, that doesn't work. But up here, my variable was on the left, and I did shade that direction. You can always, I could have chosen to move this over to here and this over to here, and it would have taken a little bit longer, but I could have forced it to happen. You can also, this is the same thing as you completely flip the whole thing around. So m, flip this sign here, and then it points in that direction. Okay. Now this is our graph. Let's do interval notation. It's always your left-hand boundary, which is a 2, and it has a bracket, comma. It goes up forever in the positive direction, so it's positive infinity, close, because infinities always get parentheses. Okay, so let's look at this one. I've got fractions in there, and of course we don't necessarily like fractions. We could kill these fractions, and that's what we would do if it were an equation, so let's do that. I'll look at every fraction that appears in the entire thing. That's here and here, and my denominators are 5 and 4, so the least common denominator would be 20. So I'm going to multiply each thing by 20. Now, this does confuse some people sometimes. Basically, think of this as just think of it as a k, like it didn't even have to distribute. So I'd have these things to multiply by 20. It doesn't matter that I'm multiplying these are still terms. Basically, I do 20 over 1 times 3/5 times k minus 2 minus 20 over 1 times 1/4 times 2k minus 7 is less than or equal to, I have to multiply both sides, so that is 20 times a 3. Now, what I was trying to say earlier is this part confuses a lot of people. If you don't understand why this 20 did not get multiplied through this as well, that's because when you multiply 3 things together, 3 times 4 times 5, it doesn't matter whether you multiply these two together first and then take that answer and multiply here, or these two together first and then multiply here. I could even do the 3 and the 5 together and then multiply that answer by 4, right? This is 3 things multiplied together. Just because one of them doesn't look like a number, that doesn't change anything. So what I'm going to do is I'm going to multiply these together, and my denominator should cancel out. The 5 and the 20, if I divide that by 5, it's a 1. Divide this by 5, it's a 4. So what do I have? I have 4 times 3, which is 12. And then I'm going to take that and multiply it by k minus 2. Minus. The same thing happens here. Divide this by 4, you get a 1. Divide this by 4, and you have a 5. So I have 5 times 1, which is 5, times 2k minus 7. And this is less than or equal to 60. So now I have a problem where I need to distribute, but I no longer have fractions, which is nice. I'm going to distribute the 12, and then distribute the negative 5. So I have 12k minus 24 minus 10k plus 35, be careful with your signs there, is less than or equal to 60. Let's combine like terms. 12k minus 10k would be 2k. And then negative 24 plus 35, that would be 11. So plus 11 is less than or equal to 60. Okay. Now let's subtract 11 from both sides. And we get 49. 2k is less than or equal to 49. Divide both sides by a 2. And I'm going to go up here to write my answer. I get k is less than or equal to 49 halves. You don't have to simplify further than that. This is a perfectly good answer. And you don't even have to necessarily think about what this value is. I take this value and I put it on here. Okay? My answers are supposed to be smaller than this number. Smaller numbers are to the left. So I shade to the left. And if you notice, our variable was on the left-hand side, and we shaded the direction the sign points. This has an equal to on it, so we're going to use a bracket. And there's our graph answer. In interval notation, it starts off at negative infinity, and it goes up to 49 halves. Infinities always get parentheses. We used a bracket here, so we use a bracket here. And that would be our answer.